In today's lesson from Unit 2.1, we're going to be taking a look at some shortcuts to proving triangles congruent. In our previous lesson, we learned that two triangles are congruent if all three pairs of corresponding sides are congruent and all three pairs of corresponding angles are congruent. So that's really 6 pieces of information that you would have to prove to be congruent in order to say that a triangle is congruent to another triangle. Today we'll explore 3 shortcuts that can be used to prove triangles congruent. In our first example, we're going to use the 3 segments below to construct a triangle. And then you're going to compare your triangle to somebody else's in the class. So to do this, you need a compass and a straight edge, or a ruler. So the first thing that we're going to do is label this first line segment, the longest line segment, as line segment AB. Okay, take your straight edge and use it to draw a line segment a little bit longer than line segment AB appears to be. Now, just so you know, I don't have a compass, so my construction is going to be an estimation, so you need to listen to my directions. So on that left-hand endpoint of your new segment, label that point A. Now take your compass, put the compass point on point A, and the pencil point on point B. Just strike a little arc to make sure that your compass is set to the length of line segment AB. Bring it down to your new line segment, put the compass point on point A, and strike an arc so it intersects your line. And that point where your arc from your compass intersects the line, label it as point B. Okay, next, come back up to your segments. In the second segment, we're going to label it AC. So again, take your compass, set the compass point on this point A, pencil point on point C, so you're marking the length of that new line segment. Okay, come down to your construction, put your compass point on point A, and strike an arc above the line, okay, with your compass setting. Your arc is going to look a little bit different than mine. Remember, I'm doing this by hand and not with a compass. Okay, we can't say where point C is going to be just yet, but what we need to do next is take our final line segment, and this is going to be line segment BC, the third side of our triangle, and set your compass to that length. So compass point on point B, pencil point so it goes through point C, and pick up your compass and turn it around so your compass point is on point B, and strike an arc so that it intersects with that first arc. Now that place where those two arcs intersect, that's point C. So label that point C, and then use your ruler to construct the lines from A to C and from B to C. Okay, now take a second, pick your paper up, pick your triangle up, and lay it on top of somebody else's in your group or at your table, and see if your two triangles overlap. Okay, they should overlap completely because they are constructed of segments with the same length. So this is our first shortcut in here. If we know 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Okay, so that's our first shortcut for today. It's also called the side-side-side postulate. And again, putting that in writing, if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. So if you're given a diagram and you have triangle A, B, C, and you see some markings for the segments that make up that triangle, and you see another triangle, let's say it's called D, E, F, and it's marked in the same way, right? Because all 3 sides of that first triangle are congruent to all 3 sides in the second triangle, then we can say that triangle ABC is congruent to triangle DEF by side, side, side. And you just use SSS to represent side, 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 congruence postulate. For our next shortcut, we're just going to do some fill in the blank, but we're also going to draw a picture for it. The SAS postulate, or the side angle side postulate. It states if two sides in the included angle of one triangle are congruent to two sides, and the included angle of another triangle, then the triangles are congruent. Okay, so in the little bit of space that you have on the worksheet, draw two triangles that appear to be the same size, same shape. In other words, draw two congruent triangles. So I'm going to stick with ABC and DEF. So let's say we know that AB is congruent to DE. So let's say if AB is congruent to DE, and let's say AC is congruent to DE, and if we know that the included angle, see how that's included between those two sides? It's in between the two sides. So if we know that angle A is congruent to angle D, then we can say that triangle ABC is congruent to triangle DEF. And then we would say they're congruent by side angle side. Just a reminder that when you write a congruent statement, your corresponding parts must be congruent. In other words, angle A congruent to angle D, angle E congruent to angle B, angle C congruent to angle F, side AB congruent to side DE, and so on. In our third shortcut, we're going to be taking a look at the ASA postulate, and this is also referred to as angle side angle. And this one starts off with if two angles and the included side of one triangle are congruent to two angles, and the included side of another triangle, then the triangles are congruent. Okay, so I know I don't have much room on your worksheet, but let's try to squeeze this one into, just so you see what it looks like. Again, draw two triangles that appear to be congruent. I've got triangle A, B, C, and D, E, F. And this postulate is different than the last one because we're going to have two pairs of congruent angles. So let's say angle A congruent to angle D, angle B congruent to angle E. And the theorem says that it's two angles, sorry, that should be plural, and the included side of one triangle are congruent to two angles and the included side of another triangle. The included side is the side in between the two pairs of angles that are marked congruent to each other. So again, triangle ABC is indeed congruent to triangle DEF, and this time it's by angle side angle. Let's squeeze that A in there. Okay, so we have our three shortcuts: side, 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 side angle side, and angle side angle. Let's see how we can use those in proofs. Okay, in example 4 here, we have a little bit of information that we know. We're going to mark up the diagram, and then we're going to try to fill in the blanks in the proof. So we're given that line segment RS is perpendicular to ST. So that means that we've got a right angle there. We also know that TU is perpendicular to ST as well, so we've got two right angles. So taking a look at step 1 in the proof, we have line segment RS perpendicular to ST, TU perpendicular to ST, and we know that that's true because that was given to us. from that information, we have the measure of angle S equals 90, and the measure of angle T would equal 90 as well. And that's by definition of perpendicular lines. So angle S is congruent to angle T. Because they have the same measure, we can just say as a reason it's the definition of congruent angles. Next, we have another piece of given information here. It says V is the midpoint of ST. So let's go ahead and say that's given, and then we'll talk about how that helps us. So V is the midpoint of line segment ST. That means that SV has to be congruent to, and we can say it as TV or VT, okay? Because that's the definition of midpoint. A midpoint is a point that divides a segment into two congruent segments. So because we were told it was a midpoint, then we know that it divides that segment into two pieces that are congruent. Okay, next we're moving on to another pair of angles here. In number 6, it says the angle RVS. Well, check it out. Angle RVS is right here. And notice that it's congruent to angle UVT. Okay, so think about that. Why are those two angles congruent? They're congruent because vertical angles are congruent. Okay, use some symbols there just to save some space. Finally, we're ready to say that our two triangles are congruent. Remember that when you name your triangles as being congruent, you have to name them so that the corresponding parts are congruent. The first triangle is easy to name. Name it any way you want. So I'm going to start with the triangle at the top. And, well, let's look at the proof statement. Okay, and see if we have it correct. So triangle RSV. So it starts at R, goes to S, and then into V. So in the second triangle, we would have to start at U, go to T, up to V. So the triangles are named so that corresponding parts are congruent. Then we just have to give a reason as to why those triangles are congruent. Remember, we want to use either side, 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 or angle, side, angle. So which do you think it is? If you said angle, side, angle, you're correct. Because we have angle here, and then the segment, and then the vertical angle. Angle here, the segment, then the vertical angle. Okay, and the next proof, you're going to do it a little bit on your own. Okay, you can see I already set up the proof a little bit because we have two pieces of given information that are very similar. We can include them together on the first line and just say that that's given. Okay, like with any proof, we have to think about what this information tells us. What do we get out of it? Now it says that E is the midpoint of TP, so that means that TE is congruent to EP. So TE congruent to PE. Then we also know that E is the midpoint of MR. So ME is congruent to RE. And the reason for knowing this is just by definition of midpoint. And we saw that in our last proof too. Okay, now we're out of given information. This is where we have to go to the diagram and see if there's anything else that we can figure out that's true about these two triangles. Okay, if you take a look, notice that we've got a pair of intersecting lines. So these two angles will be congruent to each other. Okay, we can't just name them with angle E. We have to use 3 letters because there are a lot of angles that share E as the vertex. So the first one I'll name angle TEM, and we'll say that that's congruent to angle PER. And they're congruent because vertical angles are congruent. Okay, in step 4, we're ready to say that our two triangles are congruent. And check it out, triangle TEM is congruent to triangle PER. If you think about the reason why, again, think about our shortcut list. Side, 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 angle, or angle, side, angle. And if you guess side, angle, side, you are correct. Okay, good luck on the homework and the CYU. Please ask if you need any extra help.